Hello viewers, Newton's Laws question 2, and we need to find the net force including direction in the following situations. Also determine the acceleration of an object with the stated mass for 3 distinct situations, and it's suggested that we draw a free body diagram. So question A, we have a 65 kg object, and on it we have a 17 Newton force acting south, so we've got a 17 Newton force acting south, and we've got a 4 Newton force acting north. And we need to find firstly the net force, which is going to be the overall sum of the forces, which is going to be, since they're acting in opposite directions, we have to subtract them from each other. The magnitude would be 17 minus 4, giving us 13. So F net will be 13 newtons. And the larger force is the one acting south, so it's 13 newtons south. Now the acceleration is the net force divided by the mass, because the net force is mass times acceleration, which is going to be 13 newtons was the net force. The mass is 65 kilograms, and we end up with, if we divide those by each other, we get 0.2 meters per second squared, and we need to state the direction, which is the same direction as the net force. Question B here, we have a 3.5 kilogram object. We have a 5 Newton force acting north, and we have a 9 Newton force also acting north. So these two forces are going to reinforce each other since they're acting in the same direction. That means we need to add them. So that means that the net force in this case is going to be, add them, we get 14 newtons, and the direction will be to the north. Acceleration equals the net force divided by the mass, which is, we've got a net force which is 14 divided by the mass is 3.5, so that is 4 meters per second squared acting north. And question C, let's draw our free body diagram. We have a 7 kg object. We've got a 9 Newton force acting north, so we've got 9 newtons and 9 newtons acting south as well. So in this case, we've got two forces of the same size acting in opposite directions, so they're going to cancel out, which is going to give you a net force of 0, and if the net force is 0, then the acceleration must also be 0. Okay, thanks for watching. Over and out.